Welcome back and let's prep for better jobs. Today we're solving twosum of the most popular interview question. We're given an array of integers and we need to find two numbers whose sum is equal to the target. The most straightforward way to solve this is fairly simple. We generate every combination of number pairs using two for loops and then check each sum. The time complexity for this is O of n squared and would most likely not be a passable solution for an interview just because it's too slow. So I'm not going to cover it in this video, but I will leave the code and the time complexity analysis in the comments. Now let's skip the brute force and go straight into the conceptual solution of doing this in one pass. Starting at number 2, the only possible value we can add to the 2, resulting in our target of 9, is a 7. Now that is going to be true for each value, that there exists only one solution for each number. That number is called the complement, which we can find by taking the target minus our current value. This concept of the complement value, where you take the target minus your current number and look for that in the array, is really the main concept behind how you're able to solve this in one pass. So if that's a little bit confusing for you, please pause the video and for every single number, do that equation and then you'll see how it works out. Now, the last part of this problem is that we currently have a complement value for every single index, but we need to figure out, does that complement value exist in the array? And we need to do that in constant time. So let's kind of walk through that now. If we have an array of 2, 11, 7, and 15 with a target of 9, so if we do a standard for loop through this array, we're going to first start at the number of 2. And at 2, we want to find the complement value for this number. So that is going to be done by taking the target, or 9, minus our current number of 2. So 9 minus 2 is equal to 7, and that is the value we're looking for. We do see the 7 exists, but it's further in the array, 2 spots down. And we haven't iterated that far yet, so currently there's nothing we can do to find it. So let's go to the next position in the array. So we're now at number 11, and we can do the target of 9 minus our current number 11 and get negative 2. Negative 2 does not exist anywhere in our array, so we can skip this number and go to 7. So now our current number 7, we can do our target of 9 minus 7 equals to 2. Now 2 does exist in the array, but we have a problem because we already passed the 2 in this loop, so the only way we can get to that 2 right now is we have to do another for loop. But doing that extra for loop takes us back to our brute force solution, so we can't do that. Alright, so let's recap what we did. I did a for loop, and for every single position in this array, I figured out the complement value for it. And what the problem that we ran into is we eventually hit right here. We were at I is equal to 2. Our current number was 7. And then we found the complement value was 2 for this. But the issue here is, since we didn't store anything at all, the only way to figure out that this 2 exists is you have to do another for loop at this element and figure out, do we have a 2? And that's going to be your solution of O of n squared time. But we do not want O of n squared time. We want to do this in O of n time in one pass. So let's go through this again and show exactly how to do that. First, we start at I is equal to 0. And we get a complement value of 9 minus our 2. Now, with this complement value of 7, we do know that it exists in the array, but it's further down, and we haven't gone that far in our loop yet, so let's just skip this and go to the next position. So now we're at I is equal to 1. Our complement value is going to be negative 2. Negative 2 does not exist anywhere, so let's skip this. Now we're at I is equal to 2. Our complement value is going to be 2. And now what we have is we're at number 7. We know that we need to figure out if there's a 2 in this to return. But the hint here is we already did figure out that we have a 2. Right here is I is equal to 0. If we do, our current number here is 2. And we already found that. So we want to, this is your big hint that we already computed this answer. We know that the 2 is here, so we want to cache this. So here we have our key and our value. What we do is that every single value in this array, we want to cache the value and then its index, so 2 and 0. And then we go to I is equal to 1, we cache its value, 11 and 1. And now what we do is, where I is equal to 2 again, we have the complement value of 2, and we can do a O of 1 lookup in this map and figure out, okay, we have 2. It's right there. So here we can return our index. So we do I, and our map is going to be at our complement value, and that's the whole solution. Because remember, if we do map of complement, so map of 2 is equal to 0 right here. So yeah, that's the whole solution. You every single index, you want to get the complement value, check if the complement value exists in the map. If it doesn't, we just want to put that value in the map. And then at the end, if we have no solution at all, we just return false. Lastly, I'm going to jump over to Leetcode and code this up. To start off, we want to create an empty dictionary. So I'm going to call that numbers. Now that we have our dictionary, we need to iterate through every single index in this array. So that is going going to be for I in range length of nums. Now for our current number, we want to find the associated complement value for that. So if you might remember, that's complement is equal to target minus nums of I. Now with this complement value, the first thing we want to check is, have we seen this previously in our map? So to do that, we can say if comp is in numbers. Now, if it is, we want to return that number pair. So the first number we return is our current index, and then the second index is going to be in numbers. And if you remember, the value of this hash map is going to be the index. So we pass numbers of complement. And then lastly, if we haven't seen this complement in our map, we want to add our current number in its index. That is going to be numbers of nums of I is equal to I. And then at the end, I'm going to return none. That should be everything, so we'll run it. It's accepted, and now submitting it. Passed all the test cases, so thanks for watching.